We're speaking today about an open source infrastructure for distributed manufacturing, introducing the World Tree Network. What is it about? What do we do? Create the world you want to live in. Micro-scaled, localized manufacturing. Who here has ever used a 3D printer? Who owns a 3D printer? Who has done metal laser sintering? Oh, dang! Wow. Okay, those fiber lasers are not cheap, but technology is progressing very fast, and we have to be ready for it. Or we could be ready for it, and things could be amazing. So, how do you create in the physical world? Where most of us are a bunch of devs, programmers, designers, and hype merchants. Not a ton of experience with creating in the physical world. So, how do we do it? First off, acquire raw materials. You need source materials to create with atoms in the physical world. Number two, have the right tools. You do not want to be using hand tools unless you do want to and you want to spend a lot of time. However, we're here to talk about automation. Number three, know how to make it. How do you represent recipes? How do you transmit the know-how from one person to another? Number four, actually make it. Whoa, I did the engineering thing and I started with the solution. Why? Why should we do this in the first place? Why does this even matter? Here's the state of the world today. Mass production, economies of scale require us to make things in very large quantities. So what effect does this have? You get things that are generic because individual items have to have broad appeal for the exact same item across many different people. And they should be disposable, so people have to continue to buy more. They should be cheap, so you can sell more of them. Make sure that you create a consumerist culture so you can generate demand forever. That's how business works, right? Repairability. Avoid this at all costs. People will not continue to buy if your stuff is repairable. This is optimizing for exchange value. Money. More money. So, where are we going? Micro-scaled, localized manufacturing. Making at small scale, first for yourself and your local community, and then expanding to global markets. You can make things that are unique, designed for your own needs. You can repair things, make the needed parts yourself. You can improve them, improve the parts, install them. And you can choose what quality of items to create. Because you're building for yourself first, are you going to build crap for yourself? Build good quality, built to last. Freedom to experiment. Now you can unlock innovation in the physical world that you can't when you're beholden to economies of scale. And last but not least, lasers. Play with very powerful lasers. So okay, the TLDR of that. Where we are, mass production, optimized for exchange value, more and more money, make cheap stuff that breaks and goes into the landfill. Where are we going? Microscaled, localized manufacturing, optimized for use value, longevity and utility. Create aesthetic value, spirit, soul. Why not? Tinker, experiment, innovate. Less landfill, more happiness. So, first, receive in sufficient, small enough quantities. In supply chains today, receiving non-bulk quantities is very expensive. Everything is optimized for very large amounts of items because mass production. Shipping and receiving is still mostly a manual process. You have to hire people to enter what's received, what's sent, keep track of inventory, hopefully not in spreadsheets. This is sorely needing coordination. That is the magic word. We are blockchain people. That is what we do. Okay, first off, a tool that we can use. It's called Value Flows, a universal open source protocol for representing supply chain interactions. It doesn't have great designers. It has really good software architecture. And I mean, boxes and lines, It's an open protocol. There's several decentralized projects that are making this. I will show some links at the end. But the founders of this have worked on it from various commercial endeavors for the last 25 years. Okay, so you have to pay for it. You have to pay for the stuff that you get ahead of time and before you've manufactured or sold anything. Oh, well, finance, right? Financing, supply chain financing, it's a thing. However, there's a catch. Underwriting today focuses on businesses that follow the current paradigms. You have to be making something the same or similar to existing products with demonstrable demand. You should only make iterative changes, no major evolutions. They can't calculate that in their actuarial tables. Operate at sufficient scale, utilizing well-understood industrial manufacturing tech that they can model and loan money for. None of this is very interesting. Presenting Resource Network. Resource is the ideal way to do peer-to-peer supply chain financing. It utilizes mutual credit. It exists today as business-to-business trade network. It is a technology. The CIP36 is the first blockchain-based implementation of mutual credit. It allows multilateral barter networks. So you can have a single set of parties that can only trade with each other. That's the usual way of doing this in trade financing. Or with the CIP36 tokens, the one that exists currently today is called RUSD. You can check it out. There's links at the end. Consortiums can form and agree to accept a single trade currency with each other. The currency models the balance of trade between the entities. See, here's the circular economy here. As long as these circles exist, the stuff will flow, the spice will flow. Or you can use a resource's decentralized underwriting system and make use of a more universal representation of the balance of trade, RUSD. Okay, next up, have the right tools. Automated, rapid manufacturing. Technology here is moving incredibly fast. If you are watching this talk 1 or 2 years from today, there's probably new methods that we haven't even dreamed of right now as I'm talking. However, generally, there's a few categories. Additive manufacturing, right now we have 3D printing using PLA, plastic, resin, concrete now. You can do carbon fiber. Direct metal printing, metal laser sintering, etc. Subtractive manufacturing, where you take material away. Automated milling machines, Tormach, etc. Laser cutters, water cutters, plasma cutters, CNC routers. These things can take raw materials and make just about any shape that you need for your requirements. And, of course, we have now robots. Cheap, precise stepper motors and servos are finally here. I know we've all been holding our breath. Advances in AI allow object manipulation, enhanced safety. We still need robust, flexible, and open source software for this. Almost everything is proprietary. We need good people working on this. Okay, standardize the platform. Fabrication hardware. Ignore the black. Eventually, we'll have a multi-architecture compilation for our specifications. However, for now, if we develop a standardized hardware platform for manufacturing, we'll be able to ship it and create the localized fabrication nexus. Nexi? Okay, now we need to know how to make it. Developing an open spec for representing manufacturable recipes. Knowing how. Okay, a set of instructions for a machine to execute in order to accomplish a task. This is sounding familiar. Software. All right, unsolved problem alert. Is there an open protocol for representing automation steps for making a particular geometry that can be compiled to machine-specific CNC, G-code, etc.? Email me if you know. Software changes everything. Software is zero marginal cost. You can copy and distribute it for free forever. There's instant propagation or near instant. New methods can spread mimetically and instantaneously across the world over the internet. Know-how and the ability to create will be democratized. With this, anyone can contribute, upgrade, and experiment. You have an idea for a better part? Make it. Try it out. Expand to a distributed network of localized manufacturers around the world able to understand your recipe and instantiate it anywhere. Okay, what's the best thing about the internet? There were a lot of jokes that I could put here, but I ran out of time, so I'm just going to tell you. It's collaboration. Enabling collaboration on printable digital assets. Co-making is just better. Who emails Word docs anymore? Just load up Google Docs, edit, collaborate at the same time, see where the other people are, see people flying around in Figment, make things together at the same time, even when you're remote. Okay, let's think about it. We need manufacturable 3D objects, good physics simulation to try them out without having to print them first, virtual presence, and real-time collaboration. Do we have any technology that meets these requirements? Metaverse. Yes, all the good things are in this talk. Introducing Cloud City. Collaborate on 3D modeling in VR. First of all, we have NVIDIA Omniverse, which is a set of technologies that NVIDIA is putting out to do real-time physics modeling for creating physical items. Second, we're developing Cloud City, which is an art and NFT project first and foremost. However, it is designed to become a collaborative space in which to model printable and creatable objects together. How fun. I mean, that's way more fun than shooting people. I mean, come on. Standard rapid manufacturing hardware platform, which we are working on, and open source downloadable recipes. A Creative Commons for cultural artifacts. Fork them, innovate on them, make new things. Lastly, actually make it. This is an exercise left to the audience. Join the revolution. Here's some people already doing this. Open Source Ecology is one of the forerunners. They've been at it for 15 years now. Mandelbot Ecotech, my man Scott Vaven. Here's the Mandelbot over here. Open source. And Resource, doing mutual credit, trade financing. And me, Duke at worldtree.io. Email me if you want to be involved in any way. World Tree Network Foundation, get involved. Hackers, come and help design these protocols. Donors, we're a 501c3. Everyone, let's create the world we want to live in. Thank you.